heavy pulley and common acceleration. Heavy pulley and common acceleration of two bodies connected by a string which passes over the heavy pulley. Heavy pulley and common acceleration of two bodies connected by a string which passes over a heavy pulley. So in this case, two bodies having masses m1 and m2 are connected by a string, and that string passes over a heavy pulley of mass mp, and here m1 is greater than m2. Weight of the body of mass m1, that is mg, acts vertically downwards. m1g acts vertically downwards. m1g is the weight of the body of mass m1 which acts downwards, and T1 is the tension acting in the string to which the body of mass m1 is connected. Now we can consider the weight of the another body, that is the weight of the body of mass m2, which is m2g, acts downwards. m2g is the weight of the body of mass m2 which acts downwards, and T2 is the tension. In this case, tension acting in the string on either side of the pulley are different. Tension T1 and T2 are the two tension, and A is the common acceleration with which m1 moves downwards and m2 moves upwards. In this case, mp is the mass of the pulley. mp is the mass of the pulley. Let the two bodies of mass m1 and m2 be attached to the two ends of a string which passes over a heavy pulley of mass mp, heavy pulley of mass mp. It should be mp, not capital M. It should be capital M subscript p. Considering the downward motion of m1, we get m1a equal m1g minus T1. T1 is the tension acting in the string to which the body of mass m1 is connected, or T1 equal m1g minus m1a. T1 equal m1g minus m1a. m1g minus m1a. Similarly, considering the upward motion of the body of mass m2, we get T2 equal m2g plus m2a. T2 equal m2g plus m2a. In this case, the body of mass m2 moves upwards, where T1 and T2 are the tensions acting in the string on the two sides of the heavy pulley. Therefore, T1 minus T2 equal m1 minus m2 into g minus bracket open m1 plus m2 into a. This will be the equation 2. Now the difference in tensions, that is T1 minus T2, produces T1 minus T2 produces the torque tau, produces the torque on the heavy pulley, due to which the pulley rotates. Therefore, the torque acting on the pulley is tau, and here r is the radius of the pulley. So torque is the product of perpendicular distance and the force. That's why tau equal r bracket open T1 minus T2. Here T1 minus T2 is the force. Due to torque tau, the heavy pulley of mass MP, rotates. Here we can draw the axis of the pulley, and the pulley rotates clockwise. And torque acting on the pulley will be acting along the axis. This is the torque vector tau acts along the axis and inwards. And torque tau is r into T1 minus T2. T1 and T2 are the tension acting in the string connected to the bodies M1, M2. Rotates about its own axis with an angular acceleration alpha. Therefore, tau equal I alpha. Tau equal I A by R. Since we know that tangential acceleration, here we can denote that along the axis, angular acceleration of rotation of the pulley acts. A is the tangential acceleration, and tangential acceleration A equal alpha into R, where alpha is the angular acceleration. Here A equal alpha into R. Tangential or linear acceleration A equal alpha into R, where alpha is the angular acceleration. So we get tau as R, T1 minus T2, and also we get tau as I A by R. Comparing these two expression of torque tau, we get I dot A by R equal R T1 minus T2. Or in this case, this is the heavy pulley of mass MP, or disc. Heavy pulley means disc. Moment of the pulley rotates about its own axis. R is the radius of the pulley. Moment of inertia is mp r square divided by 2. mp is the mass of the pulley. So in place of I, we can write mp r square divided by 2 A by R equal R T1 minus T2, or comma T1 minus T2 equal, that is the difference in tension, equal half mp dot A. T1 minus T2 equal 1 by 2 mp dot A. And initially we get T1 minus T2 as that one M1 minus M2 into G minus M1 plus M2 A into A. Comparing equation 1 and 2. Comparing equations 3 and 4, we get M1 minus M2 G into G minus M1 plus M2 into A equal 1 by 2 MP dot A. M1 plus M2 into A plus 1 by 2 MP into A equal M1 minus M2 into G. Therefore, A equal M1 minus M2 divided by M1 plus M2 plus MP divided by 2 bracket close into G. So this is the expression of common acceleration of two bodies which are connected to two ends of a string which passes over a heavy pulley. A equal M1 minus M2 divided by M1 plus M2 plus MP divided by 2 into G. This is the common acceleration of two bodies of mass M1 and M2 connected to the two ends of a string which passes over a heavy pulley of mass MP, capital MP. It should be capital MP.